Hello everybody, Bill Sky, the assembly guy, and today we're going to talk about how to call an assembly language function from within C and C++ in this video on Windows. Now I'm going to do another video on Linux and another video on ARM processors, which of course are Linux. So why do this? Well, first of all, assembly language, when you write an assembly language function, it's extremely compact. There's no baggage with it. There's no extra stuff like in C and C++, more C++ than C. But you don't have all of this stuff inside of the program that's generated by the compiler or inside the function that's generated by the compiler. So you might have to write a function in assembly language that does like a really fast sort or a really fast search, or the assembly language function may be the only way to actually talk to an external device. Like on a Raspberry Pi, you might have a little device that you attach to the Raspberry Pi, especially if it's a custom built device. And this happens all the time in computer engineering and computer programming. So if you don't think that this is useful, I'm not sure what to tell you, but I'll tell you one thing, it's really interesting. So let's do this on Windows, and we're just going to jump right into the coding, and we're going to talk about how to do this using Visual Studio. Okay, so I've got Windows 11 up and running, and I also have Visual Studio started. And what I'm going to do, I'm not sure what I did there, but what I'm going to do is I'm going to go ahead and create a new project. Now, I'm not going to use any of the Komanetsky templates that I made available to everybody. What I'm going to do is I'm going to select New Project and C++ Windows Console, and I'm going to click on the console app and click Next. I'm going to give it a name, CPP, calling ASM. Now we are going to do this in C later on in the video. So let's get the C++ done first. Now before you do anything, before you even build the project, what you need to do is you need to enable it for assembly language source file. So I'm going to right click on over here in the Solution Explorer. That's the solution, that's the project. I'm going to right click on that project, build dependencies, and build customizations. Now, it might take it longer for it to come up for you because this is like the fourth time I've tried to cut this particular scene of this video, and Visual Studio keeps hanging up the computer, and it ends up coming back at some point, but this is a reason why I don't like developing in an integrated development environment. But, you know, you do what you want to do. So, all right, so I'm going to click on this fourth one here, which is MASM. I'm not really sure what the MAR MASM is. That kind of has shown up just recently. I'll have to look that up. But I'm going to click on MASM and click OK. Okay, so now I'm going to expand source files, and you can see the main CPP file here. Just to make coding easier, I'm going to say using namespace std. And of course, in a production program, you may not use that. You may not even be allowed to use that in your company. But we're going to go ahead and put that there just to make it a little bit easier to code in this demonstration. All right, now let's get rid of all these comments. Not that I don't like comments, but they're kind of in the way. All right, so let's go ahead and create our first function in assembly language. And again, this will be in C++. So, or 64-bit. So let's right click on source files. I'm going to say add new item. And what I'm going to do is, oh, well, let's hold on. Let's say right click on it, add, let's say new item. Yeah, this is a little bit of a different display. There we go. So I clicked on view templates, and this is what you might see. I'm going to click on the C++ file, and down here under source.hpp, CPP, I'm going to call it asmfuncs.asm. It's really important that you put the .asm at the end. And then I'm going to just click add. And there's our assembly language program, or our assembly language source file. So from here, I'm going to say .code, and I'm just going to start putting my code in here. So let's create a very, very simple function that just returns the number 5. I know, that's totally stupid, but let's just do that, and then we'll move on to something where we actually send arguments to the program, or to the function. So I'm just going to say get5. I'm going to call my function get5 proc, and it's not going to take any arguments. So I'm just going to leave it like that. And then what I'm going to do is I'm just going to say move to RAX the number 5. Now why am I doing that? Because RAX is always the return register. whenever you call a function, and you may have seen this in my previous functions videos, whenever you call a function, it is assumed that RAX for 64-bit or EAX for 32-bit will contain the return value. I mean, even if there's no return value, you must assume that either of those registers, depending upon whether you're going to be 64 or 32-bit, they're going to be modified by the function. So before you call the function, if you want to save your EAX or RAX, it's a really good idea for you to back it up to a variable or to the stack. And that's all this is going to do. I'm just going to move R5 to RAX, and I'm going to say return, and then I'm going to say get 5 NP. All right, so let's go ahead and build it now. Now, we haven't called the get5 procedure yet, and that's the next thing we want to do. We want to actually call it. So what I'm going to do is I'm going to go over here to the CPP, my CPP file, and the first thing you need to do is you need to make sure that you tell your CPP file, source file, that you want to call the assembler language function. And assembler language, when you call it from a CPP or a C, you want to make sure that it's a C format call. And the way to do that is right before the main, you have to say extern, and I want to call this as a C function. In other words, I want to use the standard C passing of arguments, the standard C format for calling a function. And the other thing that you need to do is you need to specify what kind of data is going to be returned. Now, if you were using 32-bit, you would want to say, you could just say just int. However, we're dealing with 64-bit assembler language program. So what we're going to do is we're going to say long, and we're going to say get 5. We're going to say the name of the function, and we're going to put a void in the arguments. So this right here says that I want to return a long, which is an 8-byte integer. I'm going to call the function get5, and it's going to get no arguments. Now, the void isn't really necessary there, but I always like to put in voids just to self-document. Okay, so we've got a little problem here after I did the after I did my assembler. I believe I have to put an end down here at the very bottom of my assembler language. I find it interesting that it assembled okay the first time, and maybe it didn't assemble. Maybe it didn't assemble until we actually told the compiler that my C++ program was going to be calling it. And I seem to think that that's what was going on. So I just go ahead and put a send there, or an end there, and let's go ahead and build it. And this is why it's really important when you first start a project to build often so you can figure out what the problem is very easily. Okay, cool. So if we look at the output of the build, you can see that it's assembling asmfuncs.asm, and then it's compiling CPP, calling cpp.cpp file. Okay, so I'm going to go ahead and put some code here. And I always like to put a program ending just so I can tell that my program has finished. Okie dokie. All right, so now let's call the function. So the first thing I'm going to do is I'm going to create a long return value, make will equal to 0. And then let's call the function. So I'm going to say, let's say return value. I'm not sure why I hesitated there. Get 5. And then I'm going to see out the value from get 5 is return value. And let's make sure we spell that right. And let's build it. Wow, built the first time. Doesn't mean it's going to run right, but it built the first time. So let's go ahead and debug it without debug, or let's start without debugging and see if we get the number 5. There we go. So our get5 function works. It returned the number 5. And if you need proof of that, you can see right here that the return value was equal to 0 at the beginning. So when we did this, it actually returns. That's all the function does. It just returns the number 5. So let's go ahead and create another function inside of our assembler. And what we want to do here is we want to do something a little bit more complicated. We want to create a function that's going to take some arguments. All right, so let's call this one add2. So we're just going to take two arguments, we're going to add them together, and we're going to return that in RAX. So we're going to say add2 proc. Now this one's going to take two arguments. It's going to take the arg1, which is a keyword, and arg2, which is a keyword. All right, and let's end that. All right, so let's add some code to our function here. The first thing I'm going to do is I'm going to just put a no-op in there. And the reason I'm going to put a no-op is that I want to show you how the registers look when I'm coding my program. Now, I don't actually need this right here if I'm going to be doing it this way. In fact, I don't like using that syntax. You can put it in there, and I'll put it back in there for you. But I don't actually like using it. I like using the actual registers, the way that they're actually sent to the function, because I don't like this. I like to call it a crutch of using variables in this way in Windows assembly language, and the reason for that is because no other operating system does it that way. So and I don't know when it's going to, I don't doubt it's ever going to be taken away, but it's just something I don't like to do. So let's go ahead and see what happens. I'm going to put a no-op there, and I'm going to put a breakpoint right there. And now I got to get my C program ready. So I'm going to say extern C long add2, and it's going to take two arguments. And you don't have to put a variable name there. It really doesn't help anything. And then, well, maybe for documentation it does. And I'm going to say return value equals add2. And let's put two really easy numbers in there. I'm going to put 10 and 20. Okay, I'm going to save and build this. And then I'm going to debug it because I want to show you what the actual registers look like. So let's go ahead and start debugging. And so the program is going to stop at the breakpoint that I put on the add2 no-op, add2 procedure no-op. And I'm going to go over here to registers, and I'm going to look for 10 and 20. And if you notice, 10 is in RCX, and 20 is in RDX. So when you call a function from a C or C++ program using the C calling standard, the first argument is always in RCX and the second argument is always in RDX. So inside of your function, you may want to back those up because the program may, well, actually, I don't think the program is going to do anything. If you destroy that data in your function, I think it's okay, because when you call that function, when you call the add2 function, you're passing the arguments by value, not by reference. All right, great. So our first argument is going to be in RCX. Our second argument is going to be in RDX. Now, what is the order of arguments sent? What if I had 3 arguments or 4 arguments? Well, the way that it works in 64-bit is that when I send arguments to a function, Microsoft has decided that, okay, it's very normal to send 4 arguments to a function. Anything more than that, and that's not normal. I guess that's why they did it this way. So the first argument is in RCX, the second argument is in RDX, the third argument is in R8, and the fourth argument is in R9. Any argument out at past 4, like if you have 5 arguments, the fifth argument is going to be in the stack pointer RSP plus 40. The sixth argument is going to be in the stack pointer RSP plus 48. Then add 8 more for the 7th argument, 8 more for the 8th argument, and so forth. And you can demonstrate that to yourself. One way you can demonstrate it is that you can look at the stack pointer that you see right here, and you can call the function, send a whole bunch of arguments to it, look at the stack location, and then you can tell exactly where it is located in the stack. Now that's for 64-bit. In 32-bit, it's different. It does the calling standard is not to put the arguments inside of registers. is to actually just use the stack. The arguments are sent using the stack pointer. So the first argument would be an ESP, which is the stack pointer register, ESP plus 8, then ESP plus 12, then ESP plus 16, then ESP plus 20, because every argument is 4 bytes in size. That's just how it works. So 32-bit is quite a bit different than 64-bit. I don't really want to go through the 32-bit too much, but you can see the notes in this video and in the presentation itself or the video itself. Okay, so let's go ahead and stop this, and then let's go ahead and put some code in here. Let's put our add to code inside of our program. Now, I'm just going to grab the values from the RCX and RDX. So what I'm going to do is I'm going to move into RAX, the first argument, our first argument, and then I'm going to add to RAX, RDX, which is add our second argument. Now we don't have to do anything more. That's it. That is the end of the function. And the reason it's the end of the function is because RAX, as I said earlier in the get5, RAX is the final return register. It's the data, it's the register where you put the data that you want to return. Okay, so let's save that. And now we already got our C++ program, or function I should say, identified in the extern. We've used it here. Let's go ahead and see out it now. And let's just go ahead and copy this. And we'll just say add to. And let's go ahead and build it, and let's just run it. Let's not debug it, let's just run it. And see if we're lucky enough to have written the code correctly. Okay, so let's say debug, start without debugging. And remember, we used, oops, we have a problem. So let's go ahead and figure out what that problem is. Yep, we got a very strange exit code there. So I guess debugging it's a pretty important. So let's go ahead and put a breakpoint there. And let's debug it and see where it died. Okay, so we're going to move RCX to RAX. There's RAX. So let's step over. So there's an A there. RDX has the value of 14, which is 20. Let's put that in there. Oops, we have a problem. There's some kind of an issue here. So let's go ahead and stop it. And let's take a look. The problem is actually pretty simple. I forgot to put a return here. So yeah, very interesting. Don't forget to do that. Also, I don't remember, not a read. Let's go ahead and save and build it. Let's see if we got any kind of a warning from the compiler. No, nothing. It didn't give us any kind of a warning. Oops. So let's put an RET there to return, and let's build it. And now let's run it without debugging and see if we get the value. And we do. So we get 30. So how do we know that that's correct? Well, I'm going to go back to my CPP file, and there we go. Add to 1020. So let's do one other thing. Let's create a function that takes an array. So it's going to take two arguments. It's going to take the address of an array, and it's going to take the number of items in the array. So let's go ahead and do that. Okay, so I'm going to call this one add array. I'm going to put a no op there. I'm going to not forget to put the return, and then add array and proc. Okay. So let's go ahead. Now, our first argument is going to be the array address. So I'm going to move into RSI RCX. The first argument, array pointer. I'm going to move into RCX RDX. Now, our second argument is going to be the number of items in the array. Okay, so you can see why we put RCX into RSI first, and that's because we need RCX as a loop counter. Now, because I'm updating RSI and RCX, I might want to push those and then I'm going to want to pop them in the opposite order. We also haven't created a stack frame in this function, but that's okay for now. We just want to test it out, and we'll go ahead and create a stack frame later on. Okay, so let's create, I like to add array loop 1, and I'm going to say loop add array loop 1. We also might want to zero out 0, because that's going to be where we put the total of the array. Okay, so I'm going to add RSI to RAX. Add an array value to RAX. We're going to move. We're going to add 8 to RSI to go to the next array location. And that's it. That will add up. Now we're assuming we're sending 8-byte values in the array. Let's just assume that for now. If you're going to have a smaller array, you're going to have to do this a little bit differently. Instead of 8, you're going to say 4. So there's different things that you need to do. All right, so let's go ahead and build that. Wow, it built the first time. Okay, so let's see how this works. So now I'm going to go into CPP calling, and I'm going to copy add to, and I'm going to call this one add array. It's going to take a long because that is going to be a memory address. And then it's going to take a long, which is the number of items in the array. So now let's go ahead and create an array of longs. So long array 1. Let's just say 5 equals 10, 20. Oh, let's keep it simple. Oh, let's say 10, 20, 30, 40, 50. Now let's build this. Okay, let's call the function. So I'm going to say return value equals add array, and we're going to give it the array address, and then we're going to say that there are 5 items in the array. And then let's go ahead and copy and paste this. And let's save and build it. Okay, we have a problem here because the problem is that this is a long. So probably what we want to do is we want to say a long address. Let's see how that works. And that took it much better. So we put an asterisk there because it is a memory address. The other thing we could have done is put square brackets. Let's see how that works. And that may be better because you're documenting that you're sending an array. You're just not sending a long pointer, which is what a long array name is, but this gives it a little bit more documentation. Okay, so let's put a breakpoint on that no-op right after the add array, and let's run this. And let's just watch the assembly language code go. Okay, so I saved my RSI and my RCX. I move 0 to RAX, and let's watch how this is going to happen. Wow, looks like it's running pretty well here. Okay, so it's 96. If I right-click on this, it doesn't really let me change the way that I'm viewing it. But hexadecimal 96 definitely is the sum of all those decimal numbers. I calculated it before I did the video. All right, so what we're going to do is we're going to restore the registers, and we're going to return. We're going to go ahead and see out. Let's take a look at our output, and there it is, 150. Now, if you don't believe that that's the case, let's take a look at this array. And we've got 10, 20, that's 30, plus 30 is 60, plus 40 is 100, plus 50 is 150. Whoa, that's totally cool. All right, so let's go ahead and let it continue. And there we go. So we've got three functions. A very simple one that takes no arguments, returns a variable. Another one that takes two arguments and returns a variable. And the next one that it takes two arguments, which one of them is an array address and an integer, a long integer, and it returns a variable value. Now, there's one last thing that I want to talk about here, is that now that I've created this program, this assembly language program, I would actually like to use that. I would like to use it in other projects. Well, one way of doing this is I'm going to right-click on my project in Solution Explorer, and I'm going to say Open Folder in File Explorer. Under that, I'm going to double-click on 64-bit under Debug, and you see your asmfunctions.obj file right there. What you can do is you can copy that file to a subdirectory like c:\userDLLs or something like that. You can copy that to there, and then when you create a project, you can then have it link or have it use that obj file, that object file, as part of the runtime. So I'll put actual instructions in the video description on how you would do that. I've got them all listed here. But I want to jump into C really quickly and show you how to do this all in C. So now that we did this on C++, let's do this on C. So I'm going to create a new project, and the process is exactly the same when it comes to C and C++. So I'm going to select C++ Windows Console, select Console app, and say Next. So I'm going to call this C calling ASM. And now if you notice, it created a C calling asm.cpp file. Well, I'm going to right click on that and I'm just going to delete it and select delete. And I do have to change the configuration manager. I do have to change the build configuration because I still need to be able to assemble assembly language source files. Now, as you can see, I'm not sure why Windows or Visual Studio hasn't updated yet. It actually, yeah, it looks like Visual Studio is a little hung up. All right, cool. Okay, so it's telling me Visual Studio is busy. All right, so let's right-click on the project. Let's go to, oh, where is it? Build dependencies and build customization. Let's turn on MASM. Okay, so let's create two files. Let's create our C file. So I'm going to say source file add new item. C++ file. I'm going to call this one main.c. Do not use CPP. Use main.c and click add. I'm going to right click on it. I'm going to say add new item, and I'm going to call this one asmfuncs.asm. Make sure you put ASM, make sure C++ file is selected, and say add. So let's go ahead and just throw some assembly language code here. We're going to do the same thing we did in C++. Let's do a really easy one. I'm just going to say .code, and then I'm going to give it a name. So I'm going to just say get5. Let's put a no op in there. And then I'm going to say return. Don't forget to do that return. And then get5 np. And then let's put an n there. Now all this is going to do is it's going to return the number 5. So I'm just going to move into REX the number 5. That's all that function is going to do. So if you jump to this part of the video, you might want to jump back to the C++ portion to see more advanced functions, because I'm not going to reproduce all of that here. So go back and look at that, and it's a good idea to see both. Okay, so let's go ahead and let's create our C program. So we're going to say #include stdlib.h. Now remember, this is C. #include stdio.h. And we're going to say int main int argc char argv. We're going to say return 0. And we're going to say put s, welcome to my program. I don't think we need a \n there. And then here we're going to say put s, program ending. Again, the reason I do this is so I know that the program is ended successfully. And let's make sure we put a semicolon there and not a colon. Okay. So now we still need the extern. Now because we're in C though, we don't have to say extern C. So I'm just going to do, all I'm going to do is say extern long int get 5. Now let's make sure we did that right. So just get 5, that's correct. Okay. And now let's just create a variable. So I'm going to say long int return value equals 0. I'm going to say return value equals get 5. Again, really stupid function, but it shows you how you can call the language. And I'm going to say put, let's use a printf. So I'm going to say printf the value returned from get 5 is, and we want to give it a %LLU, which stands for long unsigned, and then put a \n and then return value. Now, if you don't know anything about printf or scanf, I'm going to be doing those videos very soon for C, but printf basically says print this string, and the %LLU stands for long unsigned value is coming. And where's that value? It's coming out of return value. All right, let's go ahead and build it. Let's make sure everything looks good. All right, good. So it assembled ASM funcs, it compiled main C, and then it linked them all together as an exe. Let's go ahead and debug this. Let's not debug it. Let's just start without debugging and see if we get our 5. And there we go. So our 5 worked. So the other functions will work exactly the same way, the way that we did them in C++. In C, the difference is that you don't say extern C in the extern. And I think that's probably the only difference. The C program uses stdlib and stdio, and everything else is pretty much the same. And we, instead of cout, we use put s and printf, and there you go. So that is calling assembler language programs or functions from a C and a C++ program. I'm going to do one of these videos on Linux as well. Hope to see you at that video.